Hello, my name is Joshua Sendigiri, Group 9 software tester, and today I'm going to be going through the test that we have done for our labeling application. As you can see over here on the left, we have our testing folder, and this includes the tst_test GUI.cpp file. Now, this contains all the code for the testing of the program. We have also included all the essential header files that are needed to test the program. Here we have our class test GUI, and in these private slots, we have all the functions that we've used to test our application. We also have in this other private slot, we also have the queue string list sort test, and this is just a sample test to test that our sorting algorithm works correctly. Now, the first few tests that I'm going to be showing today is the test GUI buttons, the test GUI checkboxes, and the test GUI combo boxes. Now, these simple tests essentially just simulate a left click on each of the buttons that we've used in our application using QTest. So QTest has a member called mouse click, and that's obviously the click of the mouse. And this is our button open image, and then Qt left button is essentially the left click button. So this, if the button cannot be clicked, then the test will fail. But as you can see over here, the test actually hasn't failed. It has actually passed for all three of them, which means that these elements of the application can actually be, these buttons, these checkboxes and combo boxes can actually be clicked. Moving on, we have our test GUI spinbox, the test spinbox key press, which is the keyboard press on the spinbox, so the up and down arrow, and we also have the spinbox mouse clicks, which is obviously the mouse click. So the test GUI spinbox is testing all the spinboxes that we have in our application. We have a pen width spinbox, vertices spinbox, a rectangle height spinbox, a rectangle width spinbox, and a square spinbox. And these are just to change the number of vertices or how the pen width is also. So essentially, each spinbox will have a range. So what we do is we set a range. We set the range. So for this specific pen box, spinbox, we have 1 to 40. So what these tests essentially do is they test the value within the spinbox range. They test a value smaller than the spinbox range, and we test a value larger than the spinbox range. Now, we don't want the user to be able to enter a value that's larger than the spinbox range, which is why we have this test. We don't want the user to be able to enter a value which is smaller than the spinbox range. So we have this test. We want the user to be able to add in a value that is within the spinbox range. That's why we have these three tests. Now, moving on to the next couple of tests, we have the test spinbox keyboard press, and this is to test the keyboard press on each of the spinboxes. So for the spinbox pen width, we set the range 1 to 40, and we also set a value which is 20. So I just chose another one which is halfway between. Now what they do is we use QTest, key click, which is a member of QTest, and this is the keyboard click on the spinbox pen width, and the Qt key up is the up arrow key on the application on the keyboard. Then it compares the set value with the actual value when you click up, and the value that should be shown is 21 from 20, because when you press the upper button on 20, it should go up to 21. And as we can see, we use the QDebug to show that this value is correct. So if we go to the keyboard press and we look at the first value, we see that the debug is 21. Now, if we check another one, if we're testing the down keyboard button press on the pen width spinbox, we have again QTest, key click on the spinbox pen width, and then the down keyboard button, the down arrow. So QCompare to compare the last value, which is 21. So let's say, from the last one, we went from 20, we pressed the up button, now we're at 21. Now if we press the down keyboard arrow, we should be back at 20. And then we use QDebug to show the value, and obviously the value is 20. Moving on to, and this is the test that we've used for each of the spin boxes to make sure that they're correctly working. Now, the last test for the spinbox is the test spinbox mouse clicks. Now, what this test spinbox mouse clicks does is, again, it sets a range for each of the spin boxes. So again, for the pen width, the range is always going to be 1 to 40. Then we set a value, which is 20, which is right in between. Now this Q size and Q size, we use Q size on the spin box pen width to which is used to declare like the two buttons, the up button and the down button on the actual spin box. So now if we move to this test, we use Q test again, which has a member of mouse click, and this has the spin box pen width, left button click on the up button. Okay, and what this does is we have the value 20, and it simulates a click on the up button to set 20 to go from 20 to 21. And then we use QDebug to show whether that is correct. So if we go back to Spinbox mouse clicks, and it is correct at 21. Now if we check another example, testing the mouse clicks on the Penwick Spinbox up and down range limit. So we have obviously our range limit is 1 to 40. So whenever the up button on the Spinbox is clicked, when it's at its limit 40, we want to compare the value. We want the value to stay at 40, which is why we have this test. If it doesn't stay at its value, then obviously that test will fail. Again, we have the value 1 to 40. This is the smallest value that can be set within this Spinbox pen width, 1. So whenever the user clicks down on the Spinbox button, we want the value to stay at 1 whenever it's at 1, because we can't have any smaller values than 1, essentially. Now, moving on to the next test, we have the test GUI line edit. Now, the line edit in our test GUI is used so that we can add a name to we can create a class name. So the first thing I did was obviously I used the QVerify to test whether the text entry the line edit is empty. Because when we open an application, the line edit must be empty. It can't just have another class. It can't have a class name already saved there. So I use the dot is empty, and then I put a message: line edit is not empty. This is if this test will fail, and the test will say this if the line edit is not empty. Now, what this does is it checks the line if the line is empty, and then we use the QDebug, the line edit class name .text, to see if the actual line edit is empty. So if we go to the line edit test, it's passed, and as you can see, it only shows 2 speech marks, which shows that the line edit is empty. Now the next test that we use in the test GUI line edit is the QTest key clicks line edit class name. Now what this does is it simulates the writing of class name test in the line edit to show that that text can actually be entered into the line edit. So what we use is we use the QCompare line edit class name to enter class name test into the line edit, just a simulation. Then we use the QDebug, which is the line QDebug to show that the test actually works. So QDebug line edit class name .text, and if we go to the test, we can see that the line edit has the test has simulated the class name test and entered it into the line edit. Moving on, the next test that we have is well, these aren't tests. These are actually these are the bubble sorts that we have that I've taken from the main window. So this is the bubble sort for ascending, as we can see over here, and we have the bubble sort for descending also over here. Now these are just used for testing the actual sorting algorithm. So if we go to the first test, to the first sorting test algorithm, sorting a test ascending, we have declared the function name over here, which includes the bubble sort, and then we have put sort test, which if we go all the way up, if we can remember, this is the sample data to see if the bubble sort correctly sorts this out. So if we go to the test and see what happens, we can see go to execute sorting test ascending. So as you can see under the test function sorting test ascending, the bubble sort has correctly sorted our QStringless sort test list. The original order was mountain, forest, hill, alleyway, riverside, and now it's alleyway, forest, hill, mountain, riverside, and that shows that the bubble sort actually does work. Now, if we look at the sorting test descending, we can see that it has also correctly sorted it descending also, because the original order is mountain, forest, hill, alleyway, riverside, and here it's riverside, mountain, hill, forest, alleyway. So it has essentially assorted it ascending and descending.